All right, geometry students, you probably saw this coming, but we are going to talk about some other parts of triangles and the fact that there are three of those parts, and if you draw all three, they run together and they create some kind of cool point. So just to review, we have a triangle. If we draw the perpendicular bisectors of each side, so that is a line that goes through the midpoint of each side and is perpendicular to it. So here's a perpendicular bisector. Here's a perpendicular bisector. And then I'm cheating, and I'm going to make this one not hit the vertex because it doesn't have to hit the vertex. There's a perpendicular bisector. This center, this point right there is called the circumcenter. It is the point that is equidistant from all the vertices of the triangle. It creates a circle that if the radius is the distance from here to here, you get a circle that hits each vertex of the triangle, and it's called the circumscribed circle. The other point that we talked about was if you take a triangle and you draw the three angle bisectors of the triangle. So the angle bisectors cuts this angle in half, cuts this angle in half, and I'm cheating. I'm going to make sure the third one goes through that point or try to cut that angle in half. Every point on an angle bisector is equidistant from the sides of the angle. So what we've created now is a point that is the same distance from here as it is from here. Sorry, it should be perpendicular there. As it is from here. If I use that distance as the radius of a circle, I now create the inscribed circle because this is the incenter. And that circle's the inscribed circle. Not beautiful drawings because they're not drawn to scale, but good enough for review. The other kinds of segments that we have not talked about are medians. And the median of a triangle is a segment that goes from the vertex to the midpoint of the opposite side. So if you know you have a median, all you can conclude is that this point would be the midpoint of BC. So in a proof, if I said AD is a median of triangle ABC, the next thing you could say is D is a midpoint definition of median. Good? If we draw all three medians of a triangle, we get a point that is called the centroid. And what's cool about the centroid, it is the center of balance or the center of mass of a triangular region. Another interesting property is that the distance from the vertex to the centroid is 2/3 of the median. So the centroid breaks the median into a segment that is 2/3 on one side and 1/3 on the other. So it doesn't break it in half. And I think that's kind of a neat little property. Another kind of segment that all triangles have, and there's three of them, are called altitudes. An altitude is a segment that is drawn from a vertex and it's perpendicular to the line containing the opposite side. I love this picture over here of the obtuse triangle. This is where kids always mess up finding that altitude. The altitude from Q is not on segment PR, but it is on line PR. Another interesting example is a right triangle. So if I draw the altitude from this point, call it Q, the altitude would be perpendicular to the opposite side. So if this is P and R, in this case, the altitude is the side of a triangle, and that's totally fine. But look at the three ways you can have an altitude, inside the triangle or outside the triangle. If I draw the altitude from P, it's right here. It's perpendicular to the opposite side. If I draw the altitude from R, it would be right here. Good? So a good point to review right now is we've introduced 3 new kinds of segments. The perpendicular bisector, not that kind of interesting segment for a triangle, but it exists. The angle bisector, which again, kind of obvious, all angles have an angle bisector. But the interesting one now is median. That goes from the vertex to the midpoint of the opposite side. And then the altitude. And the altitude is often called the height of a triangle. Those words are related, as you would imagine. But I like altitude, and it goes from the vertex perpendicular to the line containing the opposite side. So over here you have 1, 2, 3 altitudes, and notice they don't intersect. But what do intersect are the lines containing the altitudes. So if we were to look at the lines containing these 3 altitudes, so we extended this altitude, and we extended this one, and we extended this one, the lines contain them hit at a point, and that point is called the orthocenter. And ortho you can think of like orthodontist. An orthodontist makes your teeth straight. And it's related to ortho, meaning 90 degrees, or I'm not exactly sure what it means, but it has a lot to do with right angles and kind of straight lines, but we get that term orthodontist from it. But orthocenter is the point where the lines containing the altitudes meet. The only neat property I know about the orthocenter is if you look at these 4 points, A, B, C for the triangle, and then G, the orthocenter. If you pick any 3 points, the 4th point's the orthocenter. So if I choose A, B, and C, G's the orthocenter. If I choose G, C, and B, A would be the orthocenter. If I choose G, A, and C, B would be the orthocenter. That's the only property I know that's kind of neat about it. Here's an example. Let me go back. Here's an example of different triangles with their altitude. So an acute triangle, you find this orthocenter in the middle. On a right triangle, you find the orthocenter at the vertex of the right angle. And for an obtuse triangle, you find the orthocenter outside. So notice one altitude here. Trying to see, oh, it's actually on that, containing that side, and then there's the rest of it. Wait a minute. This here. Sorry, there's the altitude. My bad. I would put the right angle there so I could see it. There's the altitude, there's the altitude, there's the altitude. I don't know why they have that little blue line as that's a mistake. I feel like the blue line should be here if the blue line's trying to show the altitude. Anyway, or maybe it is. Nope, okay, red line showing the altitude. I'm wrong. I'm totally wrong. Totally misread that diagram. Sorry about that. Let me clear that so you can see it. So the altitude is the red line from here to here. The altitude is the red line from here to here. The altitude is the red line from here to here. The lines containing those 3 altitudes right there. So Algebra 2 students, you got to see me make 2 mistakes on these videos, once in the Algebra 2 video, now once here. And that's a good thing. I'm a human being, and human beings make mistakes. Just like I said in the Algebra 2 video, I leave that in there so you can see how I figure out where I made a mistake. Because it's not if you're going to make a mistake, it's when. And then when you make that mistake, what do you do or how do you catch that it's a mistake? All right, I'm pretty sure that's it for this video. Yep, that's it. Thanks for watching. Have a good night. Review the 4 points. The circumcenter, the incenter, the centroid, and the orthocenter. Review how they're created. Know those things and know the interesting properties about them. All right, have a good night. Peace.